Hello and welcome to Buildings of Tomorrow. My name is John Lester, and in this episode we'll be talking about pressure-independent control valves. Today I'm joined in the studio by Chris Kopp, who's an expert on HVAC and hydronic theory. Chris, thank you for joining us.
My pleasure, John.
Please explain to us what a pressure-independent control valve is. It's quite a mouthful.
It's quite a mouthful, right? That's why we tend to abbreviate it and talk about PICVs.
Okay,
right?
perfect.
Pressure-independent control valves,
Yeah.
because we're lazy and don't like to have long
Always.
names, right? But as the name says, pressure-independent control valve already shows we have basically two parts in it. We have a control valve part in it, like we know from other control valves, that is there to adjust the volume flow in order to match the capacity that the consumer needs. So that's normal control part.
Great, so this control valve is like the tap we have at home, that you can bring more or less water depending on what's required.
Exactly.
Okay.
Exactly. Now, the second part, which is also built into this PICV, is the pressure-independent part, which means we have a mostly or very often mechanical pressure controller, pressure differential controller that ensures a set pressure difference across this control valve. And with that, it decouples the control valve from the rest of the system.
Okay, how do you mean decouples? What does this mean for us?
It means that we create a stable condition for the control valve, and when, for example, the pump runs up, the supply pump on the production side, to serve more water to other consumers, we hold against this higher pressure from the pump. So this pressure controller basically makes sure that for the valve, for the control valve, the situation is more or less always the same, right? And it's not faced with higher pressure, lower pressure from the pumps, which of course have to match the different needs throughout the operating phases.
Okay, perfect. So no matter what is happening on the distribution side, the control valve always sees the same thing.
Yes, yeah, you can say it this way.
Perfect.
Absolutely. And of course, when we talk about these pressure-independent control valves, we also have to select the appropriate or the right hydronic circuits to work with, right? And usually we do that with throttling circuits or with injection circuits with two-way valves, because the pressure-independent control valves are two-way valves.
Okay.
So they are not built for mixing within the valve itself. They are really built to throttling and reducing or opening up the flow.
Okay, perfect. But these kinds of circuits are the ones we see more often today in the industry, correct?
Absolutely. You could say that's the way we want to go, because the throttling circuit and also the injection circuit with two-way valve, they are both variable flow when you look from the production all the way to the consumer. And that's what we want to achieve. We only want to run as much water as needed throughout the building and not as much as possible, because it has a big impact of power consumption on the pump and also with regards to heat losses or heat gains in case of chilled water systems.
Okay, amazing. So we have a component, a pressure-independent control valve, that does two things. It controls the flow, but also ensures that any pressure changes from the system are not passed through to that valve. Do you just install them and they work, or are there some preconditions that you have to meet for them to work properly?
Actually, it has an additional feature now that you mention it.
Another feature.
Another feature.
Always
yes,
good.
Exactly. And the other feature is that you can also set the nominal flow in this PICV, in this pressure-independent control valve. So rather than having a separate part to do the static balancing, to adjust the nominal flow, you can do that easily with this valve, for example, by setting a dial at the time when you install it. And so by doing that, you basically have done the hydronic balancing from a static perspective. And then the pressure-independent control part, this part of the valve, is taking care of the dynamic balancing. So if you utilize this component, you have taken care of the hydronic balancing.
Wow, so the valve actually does three things. It controls the flow, it balances statically the circuit that it's looking after, and it looks after the dynamic balancing of the system.
Yes, and also ensures the nominal flow. So when you set that correctly, you will not get more water than you're supposed to get in this consumer circuit.
Amazing.
And that's a big issue, especially in big projects it can be a deciding factor just to use the valves because it takes care of the balancing. As we know from other projects, very often that's not done, right? People tend to cut corners because it's too much effort, and then you have an issue. And I know of projects where this was really the deciding factor, besides the control part, to go with PICVs because it reduced the amount for startup of the system quite drastically, because the hydronic balancing is done. The only thing you have to do is set the nominal flow when you install it. And that's really a small thing.
A small thing. Okay, great. So pressure-independent control valves are a part of this mechanical system that not only provide better control, but also make balancing and commissioning the system easier.
Absolutely.
That's what I like to hear. Thank you very much, Chris.
My pleasure, John. Thank you.
Thank you. And thank you all for joining us on Buildings of Tomorrow. Please feel free to like, comment, or share this episode, and also subscribe to us here on this channel. I look forward to seeing you soon.